You are watching the 1.6 lesson video on solving inequalities. So let's dive right in. Important inequalities information. We've bulleted quite a few things up top here for you. Some main things that you want to remember or even recall because you talked about inequalities in the 1.5 video and the 1.5 lesson. But we know that an inequality has typically infinitely many solutions. Sometimes it can be restricted to like saying only the integers in this set or blah, blah, blah. We'll talk about some of those things later on. It's a mathematical statement that compares quantities. They're solved the exact same way we would solve equations. So we're bringing back equation stuff and we're just applying it to inequalities. The only thing that's different is interpreting the final result. So one of the main things, or some things that I think are actually really important, is I always like to write the variable on the left-hand side, even if you have to rewrite it. I think it helps answer the question better. And then also, when you divide or multiply by a negative, the inequality symbol changes directions. This is something I believe that you talked about way back in the day. I think 7th grade was when this concept was first introduced. If you're not sure about the reasons why or the proof of why, you just can't get past it, I'm sure you could find lots of stuff on the internet. Okay, so here's some examples. Example number 1, we need to solve this inequality. Negative 4a minus 20 is greater than 20. So, just like an equation, some of you may like to draw a line right down this equal sign. You don't, or well, sorry, that's not an equal sign, that's an inequality sign. That's a greater than sign. So we're going to add 20 to both sides to keep it balanced, then divide both sides by negative 4. Since we divided both sides by a negative 4, our inequality sign changes directions. And that's exactly what we have written down here in the highlighted section. Number 2, we're going to do the exact same thing, only it looks like this solving. If we drew our line down that inequality symbol, that's a greater than or equal to symbol. It looks like we did some sorting. So we recognized that the 1.8 was on the incorrect side, so we switched sides. Same thing with the negative 2y. We wanted all the y's on the left and the non-y's on the right. So anytime you switch sides, you switch signs. And then lastly, divide both sides by 1.6 to get y totally alone. 0.4 divided by 1.6 is 0.25. Okay, so there's some worked out examples. Let's try one on our own. So number 3, it says solve the inequality below and then state the smallest possible value for x in the solution set. So we have two parts here. We first need to solve. All right, what would you like to do first? I want to distribute. Is that cool? All right, let's go. So 3x plus 3. No, 3x plus 9 because we want to multiply the 3 to the x and the 3. And then the right-hand side just stays the same. I'm kind of into the sorting at this point. So let's put all of our x's on the left and then our non-x's on the right. I'm just going to drop down all the numbers that were in the right spot, but I noticed that the 5x and the plus 9 were on the wrong sides. So let's switch the signs. So if the 5x is positive on the right-hand side of the inequality, it's going to be negative on the left-hand side. And the same thing with this plus 9. It's going to become a minus 9, which keeps it easy for me. Now I have all my x's that can be grouped together. 3 minus 5, that's 2. So 2x less than or equal to negative 9 minus 3. Well, if I owe $9 and I owe $3, that's owing $12. If you weren't able to do that in your head, it's okay. Jump to your calculator and have your calculator do your integer work for you. How are we going to get 2x, or how are we going to get rid of that 2, that multiplying? You got it. Divide both sides of that inequality by 2. And when we do that, we end up with, oh, wait 1 second. Are you yelling? Have you been yelling at your screens for the past, I don't know, minute and a half? How long has it been taking me? What is 3x minus 5x? I said it was 2x. That's not right. 3x minus 5x is negative 2x. Oh my gosh. Okay, glad that that's fixed now. So am I dividing both sides by positive 2 anymore? You're right. No, I'm dividing by negative 2. And oh my gosh, if I divide both sides by a negative 2, What happens to that sign? Yes, it changes directions. Look at this magic. So x is now going to be greater than or equal to negative 12 divided by negative 2, which is a positive 6. Boom. Okay, first part done. We also need to now state the smallest possible value of x. So if x has to be bigger than 6, what is the smallest number that is bigger than or equal to 6? And I hope that all of you agree that that would be 6. So that answers that second part there. Okay, question number 4. Given 2x plus ax minus 7 is greater than negative 12, determine the largest value of a when x is equal to negative 1. Oh, this is interesting. Okay, so we got to do some substitution here, don't we? Anytime we see an x, we're going to put in negative 1. Okay, I can do this. So 2 times negative 1 plus a times negative 1 minus 7 has to be greater than negative 12. Okay, let's keep going with this. So I'm going to multiply this through. Negative 2 minus a or minus 1a, it doesn't matter to me. Minus 7 is greater than negative 12. All right, well, I have a couple choices here. I could start sorting. I could group together like terms. I'm just going to start, I don't know, let's sort. So the negative 1a is my only side, or my only variable. So that's going to be greater than, and my negative 2 and my negative 7 have to move to the other side, and then also switch signs. So that's going to be 7 plus 2, or 2 plus 7. Both of them become positive. And then that minus 12 just comes down along for the ride because that's on the right side. Whoa, what did I do here? Okay, we're back. So let's see what's going on next. All right, 7 plus 2 minus 12. Well, if you're not exactly sure what that is, we can use our calculator. That gives us negative 3. So we now have negative 1a is greater than negative 3. And you got it. We're going to divide both sides by negative 1. And oh my gosh, we're dividing both sides by a negative again. What happens to the sign? It switches. You're right. A is going to be less than 3. Now, this says determine the largest integer value. Whoa. So, the largest integer value. So, a has to be less than 3. So, what are all the integers that are smaller than 3? Well, that would be 2, 1, 0, negative 1, and so on and so forth. Which one is the largest one? That would be 2. So that's part of that answer. So always make sure you read the question and answer the final part. Okay, question number 5. Solve for x algebraically. Take a minute right now, pause this video, and see if you can solve for x. I'm going to solve it in just a minute, and then we're going to compare. Here's my first line. I just distributed that negative 3. Okay, go ahead, pause the video, try the next step. I'm going to sort because I have a lot of variables and a lot of constants. I think it's going to be the easiest. So I'm going to sort. Okay, how'd that go for you? 7x minus 12x was okay, and then the 6x and minus 9x had to move over to the x side but change signs, and the same with the plus 24 became minus 24. Okay, let's group together our like terms. And I use my calculator to help me. Notice how I did 7 minus 12 minus 6 plus 9 instead of 7x minus 12x minus 6x plus 9x. Calculators don't work in x terms, but they know how to do integers. You should get negative 2. And our last step would be divide both sides by negative 2. And dun 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 dun, x is greater than or equal to 6. Why did I swap that inequality sign again? We had a lot of that going on today, didn't we? We divided both sides by a negative. It doesn't always happen that way. It just happened that way in quite a few of these questions. Okay, let's keep going. If x is a number in the interval from 4 to 8, and it includes all of them, state all integers that satisfy this given inequality. Okay, so the first thing that we need to talk about is the integers between 4 and 8. So that would be 4, 5, 6, 7, 8. Integers, no decimals, no fractions, just positive and negative whole numbers. In this case, they're all positive. If we know that x is bigger than or equal to 6, which ones can we get rid of? Well, 4 is not bigger than or equal to 6. 5 is not bigger than or equal to 6. Is 6 bigger than or equal to 6? Sure is. So is 7 and 8. So let's box those ones off. Okay, how did we determine those values? Well, I'm just going to take a minute to pause the video and type something up. You can maybe write something down too. What did we just talk about? All right, so what did we do? Well, we solved the inequality for x and found that x is bigger than or equal to 6. And then since the second part only asks for integers between 4 and 8, well, including 4 and 8 because they were closed brackets, I decided that 6, 7, and 8 were the integers that made the inequality true.